So let's imagine you're a computer science major. You miss class and ask your friend to send you photos of their notes. Images from your friend are 20. You upload image 1 on Telegram, then an AI takes on the image and extracts the text and adds the text to a PDF. Then you upload the second image and the same process happens. But now the newly extracted text is appended to the existing PDF. You do this for all 20 images and end up with one PDF containing all the notes for the class you missed. Sounds cool? Let's build this project. Here's a demo of what we will have by the end of this video. We will divide the project into 3 parts. Part 1, having an AI that's able to extract text from the PDFs and images. Part 2, create a PDF with the extracted text from image 1 and also append text to the same PDF on subsequent images. Lastly, tying everything together on Telegram. Make sure you have the following installed on your system. Find installation links in the description. You'll also need to have an Azure account and a Telegram account. This is what the requirements.txt looks like. You can install the requirements using pip install-r requirements.txt. We will use the Azure Cognitive Services for the AI model. Head over to the Azure portal, click on Create Resource, then search for Cognitive Services. The first result from the marketplace is what we need. Click on it, then click on Create. Everything else has been left to a default. Make sure to give the service a unique name. Click on Review and Create and wait for the deployment to finish. Once done, click on Manage Keys and copy the key and endpoint and add them to the .env file. The next environmental key is a Telegram bot token API key. Head over to Telegram and search for the bot further. Type /new bot and follow the prompts. You'll need to create a unique name for your bot as well. Copy the generated token and add it to the .env file. The final .env should look like this. Starting on the main.py, we import OS for accessing files, time for sleep-related operations, Azure Computer Cloud Vision Client, and lastly .env to read environmental variables in our .env. We then load the endpoint and key we generated from Azure, then authenticate the Azure client. The Cognitive Service gives us access to 2 APIs, the Read API and the OCR API. Imagine you are in a plant that makes ketchup. Every day, the plant receives 100 kgs of tomatoes from different farmers at different times for processing. The company can make it so that the ketchup is only made when all the 100 kgs have been delivered by the farmers. After the 100 kgs come, the ketchup is made. The company decides this is not the best way to address the issue and implements a conveyor belt that takes in the tomatoes as they come. That means we are producing ketchup as the tomatoes come in. The OCR API works synchronously, meaning you will have to wait for it to completely scan the whole document to give results, like in case 1 of the ketchup plant. The Read API is asynchronous, meaning it can give partial results at a time. The OCR works best on print images, while the Read API works on print, handwritten images, and even PDFs. This makes the Read API more robust. The OCR API also works region by region, while the Read API works page by page. For this tutorial, we'll implement the Read API for its comprehensive functionality for a use case. We start by creating a function that takes in a document or an image. Then we create a results variable that will hold the results of the text extraction. The image or document is then passed on to the Read API. The read op variable contains the response from the Read API. On the response, we find the operation location field, which contains the operation ID of the extraction. As mentioned earlier, the Read API being asynchronous means we have to wait for the whole text extraction to finish, and this is where the operation ID comes in handy. The while loop will always be true while the operation status code is running or not started. We need to ensure the operational status is succeeded, and if that is true, we get to the read results. We loop through every page and get the read results. Then loop over the lines and get the extracted text. Every line is appended to the results variable we created early on. In code, this looks like this. Lastly, we return the results. Testing the functionality on abc.png works as expected. Think of every text extraction from a single image as a new page being appended after the last page on the PDF. The approach used here works like this. When the user uploads the first image, the results are appended to the PDF. Then, when they upload the second image, we create a temporary PDF with the results from the second image. We now have two PDFs. Then we create a third PDF that loops over through the first PDF and appends all content to the new PDF, and then go over the second PDF and append its pages to the third PDF. When the user appends the third image, we treat the third PDF as now the first PDF, and the process continues. I know what you're thinking. This is such a long way of doing it. I know. The ideal situation would be just appending to the first PDF directly. I spent many hours and never made it work. Should you figure it out, please raise a PR request on my GitHub. Hopping over to the code, after importing the relevant modules, we initialize an intro list. This will serve as the text every first page on the PDF will have. The first function on this file is the save to PDF, which takes in a PDF name and a list of results. We initialize the PDF and create a page on the newly created PDF and set the font we will use. Next, we take the results list and turn it into one string. From here, we loop over the string and write it to the PDF, and then save the PDF object as a PDF file with the PDF name we passed into the function. The second function is the add to PDF function that takes into arguments the PDF name and the list of results. Next, we check if the PDF we're creating exists on file, and if it doesn't, we append the intro on the first page of PDF1. If the PDF exists, we read it as PDF1. The next step is to create the temporary PDF using the results list. We do so by first generating a randomly named temporary file and then pass the name and results to the save PDF function. This creates our PDF2. The last piece of the puzzle is to read PDF1 and PDF2, then create a new PDF3 or PDF writer in this case. We then loop over PDF1, append it to the PDF writer, and do the same with PDF2. To maintain the same PDF name, we overwrite the PDF1 with the new content from PDF1 and 2. Finally, we clean up by closing all open PDFs and deleting the temporary PDF we had created. Part of the imports we need is a Telegram module. We also need to import our AI code, which we created in main.py, and our PDF functions from write2pdf.py. Make sure to load the Telegram token from our .env. To understand how the code is structured, I'll give an example of what we're trying to do. Jane and John are attending a Chinese conference on disruptive technology. John facilitates translation from Chinese to English for Jane, while Jane takes notes she will later use for her dissertation. When a Chinese speaker is on stage, John translates what is said to Jane, and Jane makes notes. Easy enough, right? Telegram works in a similar fashion. The user of our bot is a Chinese speaker on stage, and John is our updater. The updater listens to what the user is doing and passes that on to the dispatcher. The dispatcher then passes the information to a handler that does XYZ with the info being passed. We will have two handlers. The start handler is invoked when the user invokes the /start command. Commands on Telegram start with a slash. The /start handler executes the start function. The start function takes in two callbacks: the updater and the context. The context contains all the extra information pertaining the update. We start by first getting the chat ID of the current user, then send the user a message. Since every user has a unique chat ID, we will leverage this to create their PDF. Remember, the PDF is constantly being updated, so we will recycle these handlers to start a new PDF as well. So when the user sends the star command, the existing PDF is deleted on file if they have any. Moving on to the next handler, the extract text from Telegram that listens to messages from the user. Going back to the Jane and John example, let's assume Jane's dissertation is on blockchain technologies disrupting the industry. We want John to listen to everything the Chinese speaker says, but only inform Jane when the speaker mentions blockchain. This is how our message handler will work in the extract text from Telegram function that also takes in the update and the context callbacks. We want to listen to when the user uploads an image or a document. To ensure the message sent is an image or a document, we need to get the file ID, which we can retrieve from the update. I have written a separate function to handle this logic. The file handler returns a file ID of the photo or the document. If none of these are available, then an empty string is returned. If we have a file ID, we can then proceed to download the image, else we assume the user either sent a text or a GIF. GIF, tomato. First, we get the file path the image is stored on Telegram. Then we save the image to a local path using this same image name Telegram gave. We can now pass the image to our AI code. Recall, the AI returns a list of results. If the results list is greater than 0, we can proceed to adding it to the PDF. Else, we can assume the AI did not find any text on the image or document. The PDF name is the same as the chat ID as we had seen earlier on the start handler. When the results are added to the PDF, we send the user the PDF. Lastly, we delete the downloaded image on the system. Run the main.py and everything should work as seen on the demo. Going back to the Jane and John scenario, we can make it better. What if instead of the duo sitting through speakers of different emerging technologies, they only pay attention when a blockchain speaker comes on stage? Webhooks work in a similar way. They let you listen to events sent to our bot only when the user interacts with our bot. Our data changes from polling to use of webhooks. Our webhook needs a URL, and that's where Heroku and Flask come in. Still on app.py, we start by importing Flask and initializing Flask. Then turning our extract text from Telegram as a route in order to prepare our code for deployment to Heroku. We need to create a proc file. A proc file simply tells Heroku what to do after deployment. A proc file instructs Heroku that this is a Python web app, and after deploying, Heroku should run our app.py on any available port. Switching to the terminal, run Heroku create. The generated URL will serve as our webhook URL. So add that to the .env and add all changes to git and commit. Lastly, push to Heroku. We need to add our environmental variables on Heroku. On Heroku, navigate to settings, then click on reveal config vars and copy everything you had on our .env on there. Reset your dyno and your bot should now work 24/7. Thank you for sticking through the whole project. I hope to see you in the next one. Build another project with me here. Cheers.